Elastic behavior in terms of interatomic forces. Give an explanation of the elastic properties of a material in terms of interatomic oblique intermolecular forces. Elastic behavior in terms of interatomic forces. The atoms in a solid are held together by interatomic forces. The variation of potential energy U and interatomic force F with interatomic separation R are shown. When the interatomic separation R is large, the potential energy of the atoms is negative and the interatomic force is attractive. At some particular separation R0, the potential energy becomes minimum and the interatomic forces becomes zero. This separation R0 is called normal or equilibrium separation. This is that. When separation reduces below R0, the potential energy increases steeply and the interatomic forces become repulsive. Normally, the atoms occupy the positions of minimum potential energy called the positions of stable equilibrium. When a tensile or compressive force is applied on a body, its atoms are pulled apart or pushed closer together to a distance r greater than or smaller than r0 when the deforming forces are removed. The interatomic forces of attraction of like repulsions to restore the atoms to their equilibrium positions. The body regains its original size and shape. The stronger the interatomic forces, the smaller will be the displacement of atoms from the equilibrium positions, and hence greater is the elasticity or modulus of elasticity of the material. Next, explain elastic behavior of solids on the basis of mechanical spring ball model of a solid. Elastic behavior on the basis of spring ball model of a solid. The atoms in a solid may be regarded as mass points or small balls connected in three-dimensional springs. The springs represent the interatomic forces. This is called spring ball model of a solid as shown. Normally, the balls occupy the positions of minimum potential energy or zero interatomic force. When any ball is displaced from its equilibrium position, the various springs connected to it exert a resultant force on this ball. This force tends to bring the ball to its equilibrium position. This explains the elastic behavior of solid in terms of microscopic nature of the solid. Stress. Define the term stress, give its units and dimensions. Describe the different types of stress. Stress, if a body gets deformed under the action of an external force, then at each section of the body, an internal force of reaction is set up, which tends to restore the body into its original state. The internal restoring force set up per unit area of cross section of the deformed body is called stress. As the restoring force is equal and opposite to the external deforming force, therefore stress equal to applied force divided into area F by A. The SI unit of stress is Newton per meter square and the CGS unit is centimeter gram second. Unit is dyne per centimeter square. The dimensional formula of stress is M L per L to the power minus 1, T to the power minus 2. Types of stress: tensile stress, compressional stress, hydrostatic stress, tangential or shearing stress. Tensile stress. It is the restoring force set up per unit cross-sectional area of a body when the length of the body increases in the direction of the deforming force. It is also known as longitudinal stress, that is tensile stress. Next one is compressional stress. It is the restoring force set up per unit cross-sectional area of a body when its length decreases under a deforming force, that is compressional stress. Hydrostatic stress. If a body is subjected to a uniform force from all sides, then the corresponding stress is called hydrostatic stress. Tangential or shearing stress. When a deforming force acts tangentially to a surface of body, it produces a change in the shape of a body. The tangential force applied per unit area is equal to the